for section 1, we canceled the Canvas or BBCU lecture for the topic local search. So I do want to go through some of the examples that I was planning to go through during those lectures, but we did not get the chance. So here they are. And the first one is on the topic hill climbing, and it's a Boolean satisfiability problem. So the problem is basically you have a list of clauses, and we want them to be satisfied at the same time. And each clause is connected by OR, so these notations are OR, and the variables or the literals, they are connected by OR, and these clauses are connected by AND. So we basically want the whole thing to be satisfied at the same time. And what I mean by satisfied means the value should be true. So we're assigning true or false to each one of these variables. Here there are 5, such that the whole thing is satisfied. So basically we just want all 5 clauses to be true at the same time. So at the beginning, if we just randomly set the variables, say all of the variables to true, let's see, the first one is true or false or true, then it's true. Second one, same, it's true. Third one, same. Third one is false or false or false, so that one is false. So we have one of them not satisfied, and the last one is true as well. So to use hill climbing, what we're going to do is we're going to flip one of these variables from true to false and see if how many of the clauses are improved, meaning they switch from false to true, and then we pick the best one and then we continue. So here, intuitively, we just want to make the false clause to make it true. So what we can do is maybe flip C or D or E. If we flip E, then we're making the last one false. So maybe we don't want to flip E, so either C or D would work. But when we are using the computer to check it, we do not know which variable we should use to begin with. So we should always start from A. If we flip A, basically nothing changes. If we try B, and so on. So after trying A and B, when we try C, we're going to make all of them true at the same time. So C is basically the next step, and that's what hill climbing would do. So basically trying to flip all of them and see which one causes the most number of clauses to be satisfied, and then we just flip that, and then we continue the process. So here we only need one step, and then we get everything correct, then we're done. So that's the idea here. And I think this question is the same thing. Which one should we flip so that we can maximize the number of clauses satisfied? So as I said, either C or D. And here's another example from one of the past exams. So at the beginning, all of them are false. So if we set all the variables to be true, all of these are false and false, and I mean false, all false or false, which is false. And all of them are like this. Let me actually write them down. So we need to actually compare them. If we flip A, then we're going to get 4 of them to be true. And if we flip B, we're going to get 3 of them. If we flip C, we're going to get 3 of them. For B, actually I counted this wrong. It's 4 as well. And if we flip C, actually it's 3. If we flip D, 4 as well. And if we flip E, none of them. So the question is asking for the variables that we should change to maximize the number of clauses satisfied. So either A, B, or D, they all work. So you can pick either one. So on the exam, I will specify the tie-breaking rule. So if we're breaking the ties according to our alphabetical order, then we're picking A here.